Good afternoon, this is Schweitzer, and we're going to do last of our teaching problems for projectile motion. Okay. Now, for this particular problem, I'm going to throw the ball at an angle. So I'm going to throw it, person is going to draw a little picture here. The person throws a ball at 10 meters per second, and the angle to the horizon is 15 degrees. Alright, so in this situation, the ball is going to travel this kind of pathway like so and hits the ground, assuming the ground's there. Not the best drawing there, but you got the idea. So, a few things I might just note about this, okay, is that the horizontal, when you draw it like this, alright, as I move along here, this thing is going to have an x velocity, alright, and that x velocity is going to stay constant all of the time. So the x component is controlling really how far I travel horizontally. Again, we have very important. X controls horizontal. Alright, that's horizontal distance traveled. Alright, now the y component controls two things. One, time in the air. That's very important. Alright, that is one of the very first things I want to solve for. And it also controls the max height, or the height in general. But if you want max height, then that's what I gotta do. Okay. Alright, so that's that. First, I always say the first thing I want to find is time in the air. But when I'm looking at something that's got an angle like this, the first thing I do is break my angle into components. So let's go ahead and do that right here. Okay, so I have an angle that has a magnitude that's 10, an angle that is 15 degrees. I want to find the velocity in the x and the velocity in the y. Okay, so, and from there I can add in all my stuff, my initial velocities, So I'll use the cosine, the sine function here. So to find Vx is just going to be 10 times the cosine of 15. Don't forget we broke many vectors into components. So we're using our shortcut methods here. Alright, and then it's going to be 10 times the sine of 15 equals the velocity in y. Alright, so let's get those guys here. Alright, so 10 times the cosine of 15 degrees is 9.65. And that's meters per second. Let's check that. And now we got 10 times the sine of 15, and this is 2.5. Alright, so just put these up here. Velocity initial in the x direction is 9.65, and initial velocity in this direction is 2.5 meters per second. Alright, one more key point here. Acceleration in the x direction is 0. Only opposing force I have is wind drag, which we're going to consider negligible. But in the y direction, the acceleration is, when free fall is occurring on Earth, negative 9.8 meters per second. Okay. Other things you might want to note is the location at some time, that's S. Of course, they work independently. All right, and the time is the only one where they are equal to each other. All right, what's the time on both sides? All right, again, let's one of the first thing I want to do is I want that time. All right, so for this, let's use the y component. The y component gives me my time. All right, so let's start that out here. Once again, split my math into two different factors. I have my y math and I have my x math. So I'm going to go over to my y math. It's okay. This thing's going to go up and down. All I really care about is, in all intents and purposes, I'm just throwing this ball up and letting it come down. The y component knows nothing else. And it says here that my y component, my y velocity is 2.58. So whether I throw it at this 10 meters a second at a 15 degrees, or I threw it up, straight up at 2.58, they have the same exact y characteristics. They're going to go up the same amount of height and come back down. If they launched at the same exact time, they would be at the same exact location. Okay, so I want to find, in this case, then there's two ways you can solve this thing. You can solve for the max height, or you can solve for time in the air. There's two different ways you can solve this problem. I can solve for the time it takes to get to VF equals 0, or I can solve mathematically for when x returns back to 0. Let's do it both ways. Okay. All right, so I'm going to use the easier one first. VF equals VI plus AT. Now I'm only using the y component. Initial velocity is when y equals 0. Equals initial velocity 2.58. My acceleration in the y direction is negative 9.8. And I'm solving for t. All right, now this is the time it takes for my y velocity to stop. So it's going to be 2.58 divided by, so I move the this guy over here, negative 2.58 equals negative 9.8t divided by 9.8, and I get 0.26 seconds. All right, so t equals 0.26 seconds. A couple of things I might note about this. This is the time for max height. Also, if I double that, I get the total time. So t total is going to be, so total time, all right, is, what's that, 0.52 seconds. All right, done. I now know my total time in the year. All right, next one. All right, I'm going to use distance formula. And distance-wise, only in the y direction, xi plus vi, marker's falling behind a little bit, t plus 1/2 a t squared. All right, my initial location is at 0 in the y. All right, I'm going to go up to the top and come back down. And I want to know when I reach 0 again. Plus initial velocity, 2.58. Again, I'm using only the x component. T plus 1/2, all right, negative 9.8 t squared. All right, so this is going to give me 0 equals 2.58 t plus negative 4.9 t squared. All right, so this is, again, solving out. I have my A component, I have my B component, and my C component is 0. And I can then plug this into a quad solver, which you have one. And let's take a moment and go ahead and try this out. So my A component is negative 4.9. All right. My B component is 2.58. And then my C component is 0. And we want to solve this thing. Now this gives me 2 times. So note that one of them is 0 and one of them is 0.52. So what the math is telling us is that this thing is taking a path and it crosses the 0 point 2 times. Once initially and once at 0.52 seconds. Right? T equals 0.52 seconds. Same as before. You can choose how you want to solve it. Okay. All right. So next thing, what's my maximum height? Again, I'm gonna just do this thing here because I'm on the y component, so might as well just keep going here. All right. I just want to know my position at the time of max height equals xi plus vit plus 1/2 at squared. All right, I'm looking for this location at time of max height. We already know that 0.26 is max height time. Equals 0 plus initial velocity. Initial velocity is 2.58. Solve for t. Correction. T is going to be 0.26. All right. T is 0.26 and plus 1/2 negative 9.8, and it's going to be 0.26 squared. All right, so 0.26 squared. I do both components separately. Do the one value, the next 0.26 squared times 9.8 times 0.5 and negative 0.33. Let's give myself a little more room here. Okay, this component is a negative 33. The other guy, 0.26 times 2.58 equals 0.67. All right, so not much here. Let's see here. I did that math wrong here. So we'll see why I know my math is wrong. Okay, this component cannot be bigger than this component. So this one, 2.58 times 0.26. So 2.58 times 0.26 equals 0.67. That would give me a negative height, 0.67. This is not real high. 0.67. All right, and I did the math here. I think I forgot the decimal on the time there, so it's going to be 0.26 squared, yep, times 9.8 times 0.5 is 0.33. 0.33. Okay, there we go. All right, add the two together, and 0.61, 0.61 minus 0.33, and I get 0.28. All right, so in this case, my location is only 0.28 meters off the ground. So that means that this, this height, this thing's thrown relatively shallow at 15 degrees. This max height is 0.28 meters tall. Okay. If I did this at a different time, I just get a different height. All right, and I could easily do that. Max height tends to be very important. All right, so y component, x component question. Really, the only thing we can do with x is location at some time. All right, two real common locations to want to know max height, the distance traveled horizontally is typically at the end. This is the 99% of the time. How far am I across the horizontal, okay, when I hit the ground? Right here. So I just want to know my location in the x direction at time, in this case, 0.52 seconds. The t is 0.52. I could say Okay, another might be semi-common problem. Where am I horizontally when I'm at my max height? Well, this is just going to be x at 0.26 seconds. Okay, this will tell me my horizontal location when I'm at max height. Let's take a moment and just solve out the total distance traveled. Again, distance formula, xt equals xi plus vit plus 1/2 at squared. My little pencil's dragging behind me a little here. Okay, I'm only using the x component. This is the part that throws kids off. My acceleration is 0 in the x component. There's no acceleration, there's no deceleration. I'm traveling in my horizontal component only. Alright, so this is 0. What's my horizontal velocity? We solved for that earlier. Let's take a moment and go look what that was. It's just up here, and it's located right here. 9.65 meters per second. Alright, so that's what we want to use. Alright, this is going to be 9.65, and then it's just going to be the time. The time is 0.52 seconds. And this is going to give me my location at that time. So 9.65 times 0.52. So I'm traveling at 9.565 meters per second. I'm only in the air for 0.52 seconds. So if I were in the air for 1 second, I would have traveled 9.65 meters. In this case, I'm almost exactly 5.0 seconds, meters. Okay. One thing I would note is that as long as your object is not moving, okay, this is a stipulating point, as long as your object is not moving, then your angle of exit equals your angle of impact. That's a big if. This object cannot be moving. We'll do it maybe in the next problem where it's moving. If it's not moving, the velocity, exit velocity, which in this case I think was 15 or 10, then the entering velocity also is 10. All right, so 10 and 10. Other than that, I think we've solved almost all the problems that we would want to be able to solve at this point. Let's review here a little bit. How long is the ball in the air? We solved two problems for that, two ways for that. Maximum height, okay, y component. How far horizontally did I travel? That's the x component. What's my angle and velocity of impact? We did solve a little bit of that. And that's where we're going to stop for today. Thank you very much.